Ugh. Well, shit. Um, okay. So, hmm. Again, not every limit integral is just use substitution. We do have to do something with domains and stuff. Um, well, we have this n here, and n is approaching to infinity. So, we're gonna have to sort of experiment here. Um, so let's say we have tangent of x to the power of infinity. I know this sounds absurd, but we're just looking at this conceptually. Okay, no one cares about notations at this point. Come on, we're in a competition here. Um, but uh, this will equal to 0 if x is between 0 and pi over 4. And the reason is because when x to the power of infinity, x to the power of infinity will equal to 0 if uh, if x is between 0 and 1. I probably shouldn't put closed brackets. This should probably be open. But this this is true. And again, like you could just look at it like this, a half, square it, it becomes 1/4. If you cube it, it becomes 1/8. So it gets smaller. So that's why for this to equal to 0 between 0 and 1, we put it in terms of tangent x. Whenever tangent x is equal to between 0 and 1. In this case here, 0 to pi over 4. Okay? So now we have that. But then, what if it's anywhere else? If it's anywhere else, it's going to equal to infinity if x is between pi over 4, pi over 2. Because then it equals above 1. And then when it's above 1, it goes to infinity. So, okay. Now, um, what else? So, what now? Okay, we know this, but how are we gonna apply this? So, first of all, this 16x bothers me. So we're gonna have to do some u substitution here. Well, yeah. So u equal 16x. It's gonna give me the limit and approach to infinity from 0 to mother frickin' 8 pi. So it's not pi over 2, it's 8 pi now, which means now we're gonna have to freaking split this a lot of times. We're gonna have to split it so many goddamn times. Well, it's not too tedious if you see a pattern here. So notice that, okay, well, let's sort of split this up. Uh, let's say uh, the ones where it equals to 0. Let's say, so integral, this will equal to 0 for what? For what bound will this integral become 0? The bounds would be, well, starting from 0 to pi over 4, right? Okay, and then what's next? Then pi over 4, well, we can go like this. Next would just be going to infinity. Well, be careful. We're going inside. So this would be, let me put 116 here, 116 here. So this would be 0. This would be inverse tangent of infinity. Okay, because the n is inside here, 2n. Okay. Then this would be, it would equal to this if it's pi over 4, pi over 2. Okay. And then we technically keep going. Okay. And then pi over 2, 3 pi over 4. And then here at 3 pi over 4, pi. And then we keep going and going and going. And you keep going all the way to like 8 pi. Okay, we go to 8 pi here. 8 pi, that's like 32 pi over 4, so this would be 31 pi over 4. And then this would be 31 pi over 4 to like 30 pi over 4? Yeah? Okay, so at these intervals, so we're just adding them up all together, but we could do this faster, right? How many intervals here? How many intervals here? How many intervals here? So we're doing, let's see, 1. So this is pi, and this is 8 pi. So we're going by pi over 2, pi, and then I'm assuming 3 pi 2 is 2 pi. So 8 times 2, that means that we're doing this 16 times. I'm doing 8 times 2 because it's like this 2 interval is pi, and we're going up to 8 pi. So that tells me that we have 16 intervals here and 16 intervals here. Okay. Well, that's kind of neat because 16, you multiply this integral by 16, it cancels out this fraction here, 1 over 16. Cool. So what we have here is we're just going, we just have to only go from 0 to pi over 4, and then times 16 of this integral, which cancels out the fraction, and we get 0 here. The reason is because inverse tangent of 0 is equal to 0. Okay, so this whole thing is just 0. Okay. Plus pi over 4, pi over 2. That 16 times 16, that cancels out this fraction here, inverse tangent. Then plugging in infinity here gives us infinity, right? What is inverse tangent of infinity? This equals 2 pi over 2. Okay. And that's all this integral equals. It's just this. Yeah, we have these other bounds, but again, like this bound here, it's just gonna equal the same to here. Like all these other bounds, just gonna, it's kind of like it's technically equal. So because pi minus 3 pi over 4, because if you think about it, we're dealing with constants here. So this is going to equal to pi over 2, pi over 4. All these other intervals too, right? 8 pi minus 31 pi over 4. All these is just going to equal to pi over 4. So it doesn't really matter. We could just, that's why like we could just multiply it. So I know it looks illegal, but trust me, this is valid. Pi over 2 minus pi over 4 is equal to pi over 4. Pi over 4 times pi over 2. This gives us the answer, pi squared over 8. And that's it.